Are you tired of looking at the same old data sets, which consists of either an IPL analysis or some kind of pizza restaurant or a food delivery app like Zomato or Swiggy? Their data set is analyzed. Are you tired of looking at the same old data sets and seeing those end-to-end SQL and Python projects, which is nothing but a bunch of questions, bunch of very surface level questions? Those are solved, and in the end, Power BI is opened, and some easy and non-understandable charts are made, some KPI cards are made so that it looks beautiful. Are you tired of looking at all this? Well, you might be, but not today. Today, I have brought you a project that is completely made by me, from the point of ideation to downloading the dataset to data preparation and cleaning to the EDA and ultimately the analysis. Hi everyone, my name is Ayush Saraf and I welcome you all to this amazing video. This project is very close to my heart because this is something that I've been really wanting to do after learning various tools like SQL and Python. Okay, without doing any further delay, let's get started. So this project is based on credit risk and borrower analysis. The dataset is based upon the banking records of over 10,000 borrowers from, from an actual bank which is based out of US. Okay, before we begin, I would like to first show you the purpose of doing this presentation. See, when I started out on this journey of learning data analytics, I was learning all by myself. And while doing this, I saw a bunch of videos on YouTube ranging from 1.5 to 2 hours to even 3 hours, which were all about doing some kind of projects. Because what I had heard is doing projects is a sure short way of getting into the eyes of the recruiter, and it is also a really good way to practice your SQL skills. So I was like, okay, why not? I shall make a project on my own. But then I went on YouTube and I saw those same old data sets, those cricket ones or pizza restaurant ones or a music store one. I guess you all must have also seen those kind of dataset projects, right? But I wanted to do something different. See, in my perspective, any kind of analysis has just one job: to aid in the decision making. So I thought, why not take up some important problem which is persisting still today in the world and try to solve it to the best of my capacity. Although with the advent of AI, things have become quite easier, and someone who is more aware about these things can do a lot better. But there are some problems that are still not, touched by AI or will continue to persist, or something which is very behavior specific or industry specific. Okay, with this, I stumbled upon this idea of credit risk analysis, like how in today's era there are so many fintech companies coming up which provide short-term loans, and how these short-term loans can be risky at times. We have so many companies like Moneyview, then we have Kisht.in, and much more. These startups are helping the small scale business owners to take up small loans, small amount of loans, to borrow short term loans so that it can help aid in their business. Now there is a huge problem here because judging the credit worthiness of a person is really difficult in these times. Why? Because although we have all the information, like the number of credit cards a person is carrying, their income, their job title, but again, there is a factor of risk that is always lingering in these things. And through this project, I have tried to find those risks. Although I have not done anything to mitigate that risk, but in my business recommendations that I will show you later on, I have suggested some ways that from my analysis, which shows that how by following certain recommendations, we can at least keep an eye on a certain group of borrowers and minimize our risk to the maximum extent possible. Okay. And apart from that, another important purpose was to not go with the flow and to not copy paste the tutorials already present on YouTube done by someone, or copy paste those already present GitHub projects already present on GitHub repositories. Okay. Another reason was to develop a fundamental understanding of this industry, because this is something that really interested me, that how your past really matters here. Okay. And again, there are obviously many more reasons of this. So the process of the project was as follows. First, I extracted the data from the website, which I will show you right now. Then I did some data cleaning and preparation using Jupyter Notebook. Then I sent the data from Jupyter Notebook to the MS SQL server through a connection string. I will show you that also, like how I made it. Then I did the EDA in SQL, wrote some queries, found out certain really important patterns there, some that were really intriguing. Then I presented my outputs on Excel, did some kind of analysis and posted on my GitHub repository. Okay, now let's start with the process one by one. The goal of this video is not to explain you the logic of the code or like why I did this and why I did not do that. The reason, the intent behind this project is just to explain my problem solving approach and my procedure that I went through while solving this project. Initially, there was no structure. I will be very honest with this. Initially, there was no structure. When I saw the data set, which was very huge, I got little overwhelmed. I was not able to figure out as to how to even take the first step to doing this project. But with investing a lot of time and energy, and by God's grace, I was able to figure out something or the other. And then slowly and slowly, it took a lot of time, but yes, I was able to at least do some meaningful contributions to this project. Okay, now I would like to first show you the data set here from where I downloaded it. So this is the website from where I had downloaded the data set. It is called openintro.org. It has a lot of other data sets as well, but since I wanted to know more about the credit risk industry and the banking one, I downloaded this data set and did my project on this. You can see the description here, and the name of the data set is loans full schema, and this data is from Lending Club. Lending Club is an actual digital marketplace banking company based out of US, which is basically a full-time bank and NBFC as well, and it also provides short-term loans. The format, it has 10,000 observations with on the following 55 variables. Variables are basically the number of columns. So you can imagine the number of rows may be small here, but the number of columns are huge. Like there are 55 columns here. And one thing that I was really glad about when I was doing this project is that there is this data dictionary present, which is explaining all the parts of the all the variables in short, which gave me an idea as to what I can do when I have to start this project. And yes, initially I also didn't have a lot of knowledge about the certain terms which are used here. For example, debt to income ratio was something that I was not aware about. I learned about it. I even learned about certain important terminologies like credit utilization ratio. Then we have the FICO score. Then we have revolving credit and some other important concepts. So here you can read the data dictionary here, and in the end you can find out the source, the actual source here. If you click this link, then it will take you to the login page of the bank. And since it was a hassle, I downloaded it directly from here. Then various ways to download the dataset. Okay. Now I would like to show you how the dataset looked like. I had made this folder while I was doing the project. Just a minute. So here is the dataset you can see. Okay, so it has 55 variables as of now, but I did some changes in this dataset, which I will show you later on. Like there are, you can see the job title, length of the job, state. These states are of the 51 states which are present in the United States of America. Their home ownership, what is their income, if it is verified or not, the delinquency, credit lines, inquiries, uh, payment of failure of payments, any recent delinquencies or older delinquencies, installment amounts. Then we have number of debit accounts, credit accounts, total debit limit, credit limit, mortgage accounts, and so on. Even the loan amount, the term, which is either of 60 months or 36 months, which is either 5 years or 3 years. Then we have interest rate, installment, the grades which are already given by the bank. The borrower is graded by the bank on certain basis, which you do not know about. The issue month, and so on. Like this, and also the exact information about the balance, interest paid, principal paid, and so on. Okay. Now, this was the data set that I got. As I told you earlier, I was a little overwhelmed when I saw this data set because I didn't know from where to start. Like I could have done the analysis on these four parts only, like what's the amount of balance paid, or the total paid, the total percentage of people who have paid this is percentages of their balance already, their interest left out, and so on. But I took some time. I read the data set. I understood certain variables, just like I talked about, like revolving credit, credit utilization ratio, debt to income ratio, and so on. Okay. Now I transferred this dataset to my Jupyter notebook, which I would like to show you on my GitHub repository. So this is my GitHub repository here. If we will go to the project 2 lending club, this is the project that I'm talking about right now. Here you can see that I have made the project in a very structured manner so that anyone who just wants to understand this industry, the analysis part of it, the code part of it, can easily understand it without any prior knowledge. So here is a small introduction that I had given. There are certain things that I've included, like about the project, the reasons behind this project, the statement that I'm trying to solve, which are a bunch of questions like what factors separate low risk borrowers from high risk borrowers, income levels interact with loan grades, how income drives the credit behavior, and so on and so forth. Certain tools that I used and the project goal. Now, if we go to the data preparation folder here, you can see that again I have given an introduction, but we would directly go to the Jupyter notebook here, where I will show you what exactly I had done. So if you have liked this video till now, then I would request you to please share, like throw a like on this video and comment your thoughts on it, so that if this project looks really, really good, I can take your feedback and do some improvements and bring better projects in the future. Okay, so the Jupyter notebook is loaded. Now I will show you what I had done here. So first, the basic step, you import the pandas, you import the dataset, you check the dataset, like the columns, the data types, number of null values. And one thing here before we proceed further, that this data preparation and cleaning is not just about handling nulls or checking the data types or changing them. It is about understanding the data and using the data set to my advantage so that I could compress this huge information into smaller ones and do the analysis in a better manner. Now, before going further, I did some logical checks here because there is a possibility that there might be some errors in the data set. For example, I did this one, check this one first, that if the paid total is greater or equal to the interest, principal amount, and the late fees paid, and some other ones. But after this, I didn't find any um, anomaly here. Like everything was normal, everything was fine. This error was just because of the wrong variable name. The variable name was paid total, not paid late. Like the variable name was different here, I guess, but because of which it is showing an error here. And I didn't remove this error because this is something that is very normal. Like you put your variable name wrong. Okay. Then some more uh, sanity checks here, logical checks, just to see if there are no consistencies. And after that, I found out that before that, I will show you the data set here. Since this data set is huge and there are a lot of variables that come into play when you are identifying or when you're determining the credit worthiness of a person, whether it is their number of credit cards they have, number of open accounts they have, number of accounts they have, total amount, their behavior for the repayment, any past public credit events like bankruptcies, delinquencies, or tax liens, and so on and so forth. Now, since there are a huge number of variables, I thought that it is impossible for me to see and check each and every variable for each and every borrower. Also, one important thing to note here is that the weight of every variable is different for every bank. For example, Bank A might consider a recent delinquency as a major red flag than Bank B. Okay, and in similar manner, different banks have different weights, but since I do not know exactly of this bank, I thought that I can give certain weights by myself, I can assume those weights, and then we can do the further analysis here. Now, with this thought, I thought of making four flag columns here, which will show as to how, which will compress the huge number of variables into smaller ones, and I can just take one variable out of many variables and then do the analysis on that. Okay, I hope I'm making sense here and you guys are able to understand it. Now, the first column I added was the credit utilization ratio. This is a very important ratio as it helps to understand the discipline, the financial discipline of the borrower. Like if he is not overspending the limit or underspending the limit or not even using the limit. Okay. And the industry standard as per my research was around 40%. So in the later columns, I have set up the flag as 40%, like I will show you right now. Then this effective DTI was, I will show you what this effective DTI is about. So here you can see initially we have debt to income here and debt to income joint. I didn't know about this, but there are two types of applications in this dataset: an individual, where a person individually has applied for the loan, and a joint application where more than one person has jointly applied for the loan. And these and their incomes are different in terms of individual and joint, and similarly their debt to income ratio is also different. Okay, so in this effective DTI column, what I've done is I've done nothing. I've just combined these columns. Okay, here you can see, like, till here you have NA in the debt to income joint, but here you have 37.66 as for this person, right? Although their individual DTI is given, but since the application type is joint, we are concerned and more interested in the DTI, joint DTI of the application. Okay, this is just what effective DTI was about. Then here are the flags. First is the high debt burden flag, where the effective DTI is greater than 40%. This is the what the industry standards are about. Then recent delinquency flag I also made here if any delinquency is greater than or equal to 1. And then this is the severe credit event flag, which talks about collection amount, bankruptcy, or tax lien. If an amount is recovered through recovery agents, then it is also a red flag of that borrower. So I considered it as an important credit event, and I included it in that same flag. Then we have the high credit stress flag, which is based on the credit utilization ratio and the number of revolving credit cards that a person has. After that, I did some checks here. Like here you can see the new flags, which are in the form of true and false. Then what I did was I combined all those four flags into one flag. I've mentioned the reasons here, as you can see. Calculating a risk intensity score because it won't make sense to do analysis on four different flags. So basically what I did was, if initially there were around 10 to 15 columns which talked about the behavior of a borrower, I compressed them into four, and now I'm compressing those four into one again so that it becomes less and less complex. Okay, and here I have assumed that these four flags are equal in nature. Okay, but there are cases where this might come in handy, because of which I did not drop the flag columns here, and I kept those four flag columns and the risk intensity score intact. Here I calculate the risk intensity score by calculating the mean of the four flags. Then in the last, I established a connection string using SQL Alchemy. Uh, while I was doing this connection string, I studied a little bit about networks, ports, IP addresses, the DB drivers which are used to uh, talk, like how DB drivers talk between the SQL Alchemy and the SQL Server. Okay, how ODBC driver is the specific driver for SQL Server, and how we have these functions of trusted connection and trusted server certificate. Okay, after this, I established the connection string and exported this data set into the MS SQL Server. Okay, with this, the data preparation part comes to an end. Now we will go to the next part, which is the analysis part. Okay, so before we go to the EDA part, the exploratory data analysis part, I would like to first show you how our final dataset looks like. So the initial columns are same, there are no such differences. Okay, from here you can see that we have the credit utilization ratio, the correct paid total. This was the logical check that I had done earlier, and later on I thought of making this as an important flag, as a different column, so that I can check if there are some problems here and there or not. The difference of the paid total and the sum of principal payment, interest payment, and late fees. Then we have the effective DTI. Then the four flags, the risk intensity score, which is in the range of 0, 25, 50, 75, or 100. And this income bucket was later on made by me in SQL, because while I was doing the data preparation part, it did not click me that income buckets are an important part of doing data analysis and understanding how different segments of income groups behave across the borrowings. I created this column in SQL later on. Now we can go to the EDA part here. I will show you. So as told earlier, so basically this project is divided into 5 parts. Okay, the first section talks about portfolio health and baseline risk profiling, wherein I have done basic analysis as to understand how the portfolio health is, how the amount of loans and the number of loans are distributed on the basis of different segments, on the basis of grades, on the basis of income buckets, or on the basis of on different basis. Okay. Then in section 2, I try to understand the credit behavior and early risk signals, like how certain events, and this is the section where the flags that I had created come in handy. In section 3, we focus on grade, income, and risk concentration, like how we had different grades, grade and subgrade, and on those columns, I've done the analysis. In section 4, I have understood the credit usage pattern and borrowing behavior. Here, I have made several different uh, buckets based on the revolving credit balances and the number of credit cards that a person is having, or their past delinquencies, or how frequent they are, as how frequently they repay their loans, and so on. And in the last section, I have found out the stability indicators like home ownership and income and verified income. And on the basis of that I have done some analysis here. Now we can jump to the EDA part. I've explained the individual sections here in my README as well. So here I won't show you all the like what I did and like all the codes that I've written. I will show you like whatever the logic I had, how I thought, and how I went through it. As initially told, this project had no structure, but with writing queries, I got to have an understanding that there are certain patterns that can emerge while doing this project. So instead of fussing over it, that I do not know what to do, I do not know what exact questions to solve, because that is not the way exactly. Just started the project and saw where it takes me. Okay, and in the end, I segregated all the queries, all the questions that I had into several sections. So as told earlier, section 1 is about portfolio health, and here I just basic basic EDA part. Okay, here I done some again data preparation, because here the in Python pandas the null values are showed as nan, but in the data set the problem was instead of there was a different format of nan, because of which Python did not read that nan as null values. So when I imported the data set and checked it in the SQL server, I saw that instead of null values it is written nan, as you can see the spelling here. NaN. Okay, so I had to change this NaN to null in certain columns. This is what I did. Then I did some basic querying here. Counts based on loan status, the total loan based on risk intensity score or flag. These are the different codes I had created. I'll show you some of them. For example, if I show you the section 2.1, this is many of the different codes that I had written. Okay, here I'm calculating uh, loan amount with no risk, with moderate risk, with high risk, okay, and so on and so forth. So this section is basically nothing but the codes part, and this is what I'm really excited about, because in this folder I have uploaded all the outputs of individual queries in the form of Excel files, and I will show you these Excel files right now. So if I go to my folder on the desktop, I'll open all of them at once. Okay, so this one is of section 3. Like I will show you the other sections as well. So in section 3, you can see that I had done this. I had pasted all the table outputs on MS Excel. Like in the first table, you can see how on the basis of grades, the total loans are disbursed. This is the total amount, the average risk score, percent of loan with amount of loan with no risk, moderate risk, and high risk. Similarly, this is the income buckets that I had made, which I had showed you in the data set. The percentage of high risk loans given to a grid in a particular bucket. Okay, here I have also written the interpretation. Like out of the total loans given, so if we see this cell talks about out of the total loans given to the income bucket of less than $40,000, 16.04% of loans are high risk and of A grade, and so on. Okay, so basically these all these loans are high risk loans, but these are segregated on the basis of income bucket and their respective grades. Okay. Now this one is on the basis of particular income bucket. Okay. Here you can see out of the total loans given to an income bucket of less than $40,000 and grade A, 1.96% are high risk. Okay. And here I mentioned that how high risk means when the risk intensity score is greater than equal to 50. Okay. Then this is another small table that I had made. Okay, so this is what section 3 looked like. Coming to section 2 I had to make different subsections here to have a better understanding. Like here I have made some CRU buckets and I have explained these CRU buckets here. Like how, for example, if we see this table, the CRU debt bucket ones, how we have low util low debt, which means that the credit utilization ratio is less than 50 and debt to income is less than 25. Okay, now how I determine these exact numbers? Again, I searched on Google and ChatGPT, and I used whatever the industry standards were. And then you can see, for example, you can see that 65% of the loans are have high utility and low debt. Okay. Here again, we have some more buckets like no credit stress and credit stress, severe event on the basis of there is some collection agent, recovery or bankruptcy or tax lien, or if we have a public record and so on. So you can see in our data set currently, there are only 2.98% or 3% of loans which are high risk and they have a clean public record. But someone who had a severe public event in the past, there there are 33%, approximately 33% of the loans are of high risk in that case. Okay, so in this way, I had created these Excel tables, and then after this, I started reading the tables one by one. I first, did some data formatting here. As you can see, like there were data bars in some of the cells. I did some data formatting so that it looks better and easier to understand. And then after that, I did my entire analysis here, section by section. As you can see, if I open the section one, it shows that how 93.7% of loans are current and how there are only less than 1% of less than 0.1% of loans have a charge off rate, basically which have late fees. Okay, total portfolio amount which is $163 million approximately, the risk distribution grid analysis, and so on and so forth. In the end, I have also given the overall conclusion here that how 50% of the loans, 52% of the loans showed some kind of risk. Okay, for example, if I show you section 4, okay, here you can see normal card users who have only 2 to 3 cards have highest risk segment. This is a very interesting uh, finding of mine where I saw that the moderate amount of card users were more riskier than others who had either zero card users or a huge number of card users. Okay, here you can see the extreme card users were always in the highest income group and they had only moderate risk levels. Okay. The safer segments were people with transactors who paid in full. The transactors, meaning I have given in the Excel table, like they had the lowest average risk score and lowest high risk loan percentage, and so on. So from this you can read the entire analysis here, whatever I had done individually. If I open in section 5, you can see that renters are the highest risk segment. Mortgage holders are the safest segment, which is something that is kind of paradoxical because they already have loans, they already have mortgages, but still their overall risk was lower. And here again, in short, I have done some analysis that if someone has a new job and own home, they have slightly elevated risk. New job in the sense that their job length is less. Again, the exact numbers for it were derived from either my common sense or whatever I thought or whatever the industry standards were as per ChatGPT and Google. Okay. Now with this, we come to the last part, which is my project journey and key insights that I had shared on this repository. This is the entire journey of mine which I had written. I thought that uh, I should share this. There are some errors here which I would fix later on. Here are the key insights, which are the most important ones. For example, moderate users are often riskier than extreme users, which we right now just discovered. Another key finding here was that credit behavior mattered more than income. Okay, like there were people from different income groups, but it didn't matter as far as their behavior mattered a lot. Then I also discovered some small borrower segments. For example, people who had low income and were graded as E and had some kind of past delinquency with a higher CRU. These kind of borrowers exhibited extremely high levels of risk concentration. Okay, some strategic recommendations from my side, which I thought would be really good. Okay, that how we can grow our portfolio in certain stable segments, which are target grades A to C. Then apply tighter controls on high stress borrowers. And also, I found out that the grades C and D ones, they were kind of underpriced. Their interest rates were not as high as they should be. Although they were little riskier, their interest rates should be higher than currently what we had. Then how behavior is really important part. And one more thing that I really found important is that how not just one singular factor affects, but a multitude of factors when considered into combination give you the exact result. Like just like in the last part I've written, how certain risk concentrations occur in particular combinations like lower income and grade, higher income, then mid grades, and so on. So with this, we come to the end of our project. This is the entire explanation that I really wanted to do so that anyone who sees this has an idea of whatever I've done. And I hope you really like this video. I hope you really like this project and you got to have an understanding of how a project can be approached by someone. And like, although I will say, I will accept this that this project might not have been this structured. Okay, there are a lot of flaws in it if one discovers, if one goes through it thoroughly. But what I think is I did my best. I didn't follow any kind of YouTube tutorial or followed or copy pasted some kind of project already done by someone else just so that I can show it as my portfolio. This is my own original work. And yes, that is all about. That is all I want to talk about here. And thank you so much for watching this video. Have a great day.